Hey everyone, welcome back. Today we're going to look at word problems that involve linear systems. If you've completed the previous linear systems videos, then today's lesson will be a lot easier for you. So let's dive right in. Example 1. There was a fundraiser event that was selling hot dogs and hamburgers. 64 items were sold in total and they received $113.25. If a hot dog was sold for $1.50 and a hamburger was sold for $2.25, then how many of each were sold? So the first thing we're going to notice is let's write X to represent number of hot dogs and Y to represent number of hamburgers. And so we know that the hot dogs and hamburgers must be 64 items in total, right? So X plus Y is 64. Next, we're going to look at the cost here. We know that it's $1.50 per hot dog, so $1.50 times X, plus $2.25 for each hamburger, so that means $2.25 times Y. And this total has to be $113.25. And so this is our system of linear equations right here. We have two equations and two unknowns. And so we're going to solve this by substitution. We're going to isolate y, so negative x plus 64, and we're going to plug that into equation 2. So this y is being plugged in like that. And so we distribute 225 as such. Now we have 150 minus 225, which gives negative 0.75. We're going to go minus 144 to both sides. So now we have something x equals another number. And we want x on its own, so we're going to divide by negative 0.75 on both sides, and we get x equals 41. And so we're going to take that x equals 41 and plug it into our first equation, and we get y equals 23. And so whenever you have a word problem, you always want to give a word solution at the end. And so there you go. They sold 41 hot dogs and 23 hamburgers. Okay, example number 2. A big box contains 89 marbles. Some are red and some are blue. The marbles weigh 23,500 grams altogether. A red marble weighs 200 grams and a blue marble weighs 350 grams. How many marbles are there of each color? So it doesn't have to be x and y are variables. We're going to go r and b here. R for red marbles and b for blue marbles. And so we know from our problem that the big box contains 89, so r plus b equals 89. And then the next equation has to do with the weight. 200 for the red, so 200 times r, and 350 grams for the blue. For every blue it's 350, so it's times b like that. And this sum must be 23,500 like that. And so here is our system of linear equations. So we're going to also do it by substitution in this case. So we're going to go r equals negative b plus 89. We're going to plug that r into our second equation, so 200 times r as such. We're going to distribute the 200, so we get this here. 350 minus 200 gives 150b like that. We're going to go minus 17,800 on both sides, so we have 150b equals 5,700. Divide by 150 on both sides, we get b equals 38. So the number of blue balls is 38. We're going to take that number and plug it into equation 1 like that, and we get r equals 51. So here's our final sentence here. There are 51 red marbles and 38 blue marbles. Okay, example 3. Sam has a bag of 50 coins made up of quarters and loonies. So that's a $1 coin if you don't come from Canada. That's what we use, a $1 coin called a loonie. And so if he has a total of $32.75, how many of each coin does he have? So here we're going to go and let Q represent number of quarters, L to represent number of loonies. So we know that the number of coins is 50, so Q plus L equals 50 like that. And for the amount of value, we know it's 0.25 per quarter, right? 25 cents per quarter. And then 1 times L. For every loonie, you get $1, so just L like that. And that total equals $32.75. And you can see here from this linear system, elimination would be a good idea because it's L and L like that. It'd be very quick. But I'm going to solve it by substitution here. So isolate L, plug L into our second equation like that. 0.25q minus 1q is negative 0.75q. Minus 50 to both sides, so we get negative 1725. Divide by 0.75, negative 0.75 on both sides, we get q equals 23. Plug in q equals 23 into our first equation, and we get L equals 27. So there are 23 quarters and 27 loonies. Okay, example 4. The sum of two numbers is 5, and the difference is 3. Find the value of those numbers. So here we have sum of two numbers, x plus y is 5, right? So the sum is 5. And then the difference, x minus y, is 3, like that. And so we're going to solve this by elimination, right? We're going to add the two equations together, and we get 2x equals 8, which gives x equals 4. We're going to plug x equals 4 into our first equation, and this gives us y equals 1. And so the two numbers are 4 and 1. Okay, time for some practice. Very important. So a cafeteria is selling slices of pizza and poutines. The cost is $3.50 for a slice and $4.25 for a poutine. 94 items were sold in total, bringing in a total of $360.50. How many of each were sold? So go ahead and pause the video and answer that. Okay, we're back. So we're going to let x represent number of slices, y represent number of poutines. And we know that x plus y is 94, right? 94 items in total. We know that it's $3.50 for a slice, so $3.50 times x plus $4.25 times y for poutine. And this total will be $360.50, like that. And given the system that we have here, substitution would be best. So we're going to isolate x like that, plug it into equation 2, and so we have this as such. Distribute the $3.50 like that. 425 minus 350 gives 0.75 like that. We're going to go minus 329 to both sides, so we have 0.75y equals 31.5. Divide by 0.75 both sides, we get y equals 42. We're then going to take that y equals 42, plug it into equation 1, and we get x equals 52. So the cafeteria sold 52 slices and 42 poutines. Okay, practice number 2. At a fair, they sell juice for 2 tokens and soda for 3 tokens. They sold 79 items in total and collected 196 tokens. How many of each item was sold? Go ahead and pause the video and answer that. Okay, we're back. So we're going to let x represent number of juices and y represent number of sodas. We know that combined they sold 79 like that in total. And so we have 2 tokens per juice and 3 tokens per y, giving a total of 196 tokens like that. So here you could do elimination if you wanted to. It wouldn't be too difficult. I'm going to solve it by substitution here. So we isolate x, plug that into our second equation as such. Distribute the 2, minus 158 to both sides, and we get y equals 38. Taking that, plugging into equation 1, we get x equals 41. So they sold 41 juices and 38 sodas. Okay, practice number 3. So we want to pay very close attention to the wording in this problem. And so the sum of 3 times a number plus 4 times a second number is 18. The difference of the first number and 2 times the second number is negative 4. So find the value of those two numbers. So go ahead and pause the video and answer that. Okay, we're back. So we have the sum of 3 times the number, 3x, plus 4 times a second number is 18, like that. And the difference, minus, of the first number and 2 times the second number is -4. And so we're going to solve this system by elimination. So we're going to go 2 times line 2, so 2x minus 4y minus 8. We are going to add them to get 5x equals 10, and so we get x equals 2. We're going to plug that into equation number 2 here, and so we get 2 minus 2y equals -4, which brings y equals 3. And so the two numbers are 2 and 3. And that's it. It's that easy. I'll see you guys in the next video.